welcome to our presentation on deforestation and the Amazon and tropical rainforest impact on carbon emissions. Before we talk about tropical forests and the Amazon, we have to talk about carbon sinks, which are environments that are able to absorb carbon dioxide from the atmosphere. So they're taking that carbon dioxide out of the atmosphere. Three major carbon sinks on Earth are the ocean, the northern hemisphere forests, and the tropical rainforests. Although tropical rainforests are one of the three major carbon sinks, they tend to have a neutral effect on the carbon cycle most years. That means most years they emit as much carbon dioxide back into the atmosphere as they have absorbed. Essentially, this means they're putting out as much carbon dioxide as they're taking in. This is through respiration, forest fires, etc. But they're not always neutral. It's well documented that tropical rainforests can vary from year to year. It's fairly well documented that in warmer years, tropical rainforests switch from being a carbon sink to being a carbon source, meaning that tropical rainforests are putting more carbon dioxide into the atmosphere than they're taking out of the atmosphere in these warmer years. During these warmer years, the tropical rainforests are respirating more, therefore they're releasing more carbon dioxide. These warmer years typically tend to be El Nino years, which, as we know, are years where it's warmer. For example, during these El Nino years in Southeast Asia, there's an increase in forest fires. This is particularly bad when these forest fires occur in the peatlands of Southeast Asia. Peat can hold a lot of carbon dioxide, so when it's lit on fire because of these forest fires, it then emits this carbon dioxide back into the atmosphere. But peat isn't limited to Southeast Asia. Studies show that peat has increased by as much as 50% in the forests of the Congo and in the forests of the Amazon. This is troubling because, as I previously mentioned, peat can hold a lot of carbon dioxide. Studies also show that in an El Nino year, the tropical rainforests emit 2.7 pgc of carbon dioxide. This is extremely troubling because in other years, rainforests emit a maximum of 1 pgc, averaging more somewhere between 0.5 and 0.8 pgc. This means that in El Nino years, the rainforests are emitting almost 3 times as much carbon dioxide as they are in other years. As I mentioned, the tropical rainforests are one of the 3 major carbon sinks in our ecosystem. This means that they're very important to the balancing of carbon dioxide in our atmosphere. But unfortunately, deforestation also contributes to tropical rainforest carbon emission as well. And current trends suggest an increase in deforestation in future years, which is troublesome, seeing as deforestation leads to a decrease in tropical forest land that can act as a carbon sink and absorb and store that carbon dioxide from the atmosphere.
So now we have the Amazon's specific relationship to carbon. So initially, it's thought that the Amazon was canceling out the amount of carbon that was being emitted, but in the case study that we will follow with, it is now turning out to be creating more carbon than it is absorbing. And so a large-scale integrating indicator of the state of the ecosystem is its greenhouse gas balance, so mainly the carbon balance. Luciana V. Gotti's team in Brazil discovered that total carbon emissions were more noteworthy in the eastern Amazonia than in the western part, which is generally because of spatial contrasts in carbon monoxide determined free emissions. And so the southeastern Amazonia specifically acts as a net carbon source, meaning total carbon flux minus fire emissions to the atmosphere. And so here we have a representation of the carbon cycle where you can see where carbon flows through the rainforest. So, to put the human impact on the Amazon into perspective, over the past 40 to 50 years, human effects have progressively influenced Amazonia, bringing about a rainforest loss of around 17% of which 14% has been converted for farm usage, which broken down is 89% field and 10% agricultural land. And so the removal of rainforests causes an increment in temperature and decreases evapotranspiration, and has been displayed to lessen precipitation downwind of deforested regions. To document the direct effects of the human impact on the Amazon, notably regional deforestation and selective logging, has led to the corruption of neighboring rainforests, which makes them actually more susceptible to fire, which just further advances the further corruption of Amazonia as a whole. And now these impacts are additionally advanced by the temperature increases brought about by the diminishing of forest cover, and are superimposed on the background of the entire world's global warming. And as we can see in this photo, this is what has been mostly affected by deforestation, which apparently has increased severely with Brazil's current leadership under Bolsonaro. So the specific case study, Gadi's case study of Amazonia, went in depth into what we are now seeing happening in the Amazon that is causing a carbon sink. And to demonstrate the human impact on the Amazon, Gadi and her team examined 40 years of temperature and precipitation information over Amazonia to show the connection between deforestation historically and the diminishing of precipitation and rising temperatures, primarily during the dry season, with various patterns noticed for eastern and western Amazonia. Now, these regions of influence for the foresights differ substantially with regard to human impact, in particular deforestation. In Gadi's case study of Amazonia, the east-west difference in total flux can be explained mainly on the basis of CO-based fire emissions and burned area. However, the dry season climate trends and the historically landmark increase in deforestation, possibly caused by Bolsonaro, and degradation in the east make the area more susceptible to fire. Deforestation in eastern Amazonia may be reducing evapotranspiration, which in turn may be reducing the recycling of water vapor that is transported to the western Amazonia, which throws off the entire carbon cycle. So, in conclusion, the trends of regional climate and land disturbance over the past 40 years in Amazonia seem to indicate that they are tightly intertwined. The spatial correspondence of these trends with carbon fluxes between 2010 and 2018 suggests that such interactions may have long-term effects on the Amazonian carbon balance, as the Amazon now starts to create more carbon than it absorbs, making what was originally a huge helper in eliminating carbon emissions through its absorption properties now becoming a carbon creator, which has severe effects on our environment by throwing off the natural processes. Now we have the effects of forest fires and the CO2 in the atmosphere. So in a recent study pointed out that after 30 years, burned area still is a CO2 source to the atmosphere, of which 73% resulted from subsequent tree mortality and decomposition. And then we see that this decomposition emission could not be compensated by CO2 uptake by photosynthesis. For undisturbed forests, increasing temperatures and moisture stress may increase tree mortality, death, and negatively affect photosynthetic carbon uptake by trees via a decline in photosynthetic capacity. Moreover, higher air temperatures generally lead to higher rates of soil carbon decomposition in both intact forests and disturbed land.
The current trends in deforestation and carbon emissions predict that in the near future, the tropical rainforest won't be a carbon sink at all. In fact, it will switch completely to being a carbon source. In order to achieve the Paris Climate Change Agreement to keep the global warming below 2 degrees Celsius, ideally below 1.5, we need policy to help us stop and reverse this deforestation and degradation. Without reversal of deforestation and degradation, this goal will be nearly impossible to meet. Fortunately, at COP19, which was held in Warsaw in 2013, the UNFCCC conference came up with a plan to help reverse and stop deforestation and degradation, which includes with 3 comprehensive steps. The first being developing national strategies or plans of actions from each nation. The second being implementing those strategies and plans and then measuring the results. And the third, then evolving those plans and strategies into results-based actions that are fully measured, which hopefully will help stop and reverse deforestation and degradation, therefore protecting our tropical rainforests as a carbon sink and preventing them from becoming a carbon source.